of the task and the known ability or the trust that I already have in a particular system. So I can trust, for example, my smart assistant to turn on my light or turn off my light or to set a timer, and I'm perfectly happy that most of the time that's going to work correctly. But when it comes to larger systems like ChatGPT or a co-pilot, I tend to treat it as a intern, as a very junior engineer, and I need to be very specific about what I want. And for me, generally, others have described it as they can describe the problem and then they get a solution or a set of solutions with code for whatever they're trying to implement. For me, that maybe I'm just bad at prompting, but I don't trust these systems to this extent. It doesn't work for me. I have to give bite-sized chunks and always test. So you can trust I trust the systems only to the extent that I can also validate what's happening. More of an anecdotal experience for me. I was trying to prepare for a virtual race. I have a simulated racing gear next to me to be able to. I can't detach it right now, but so I can go racing in virtual reality. And I didn't know one track. So I asked Gemini, can you walk me through the track? What is the sequence of turns? And I'll remember it and I'm going to be ready for it. Gemini told me first turn, left, fast, right, fast, third, left, fast, whatever. I end up at my computer and actually sit down and look at the map, and it's the complete opposite. It's right first, not left. So and super slow. And that's where everything started unraveling. There exists, I mean, I'm sure there are other stacks that are not Gemini that are more like Perplexity or something that also provides sources for what they're saying. But in the current flow, for me, it's very difficult to trust what they're saying. I need to always verify. But with something like Copilot, where it's a small bit of code, I can just quickly run it, check that it's okay, something like that. That's the level of trust I have.
So would you say it depends on the magnitude of data you're giving to the model, or is it just whether you can verify it or not?
I think it's whether I can. I think it depends on a balance of things. It's how creative is the task in itself, and if I feel like realistically, this example that I just gave about simulated racing is kind of niche. It's not something that most people know. I don't think there is that much content online that people can scrape to figure out what I just asked. So if it's a niche topic, maybe it's neuromorphics, even that, I mean, it hallucinates okay, never mind. Not that it hallucinates, but it sometimes these AI agents take everything at face value. You can say, I summarize this paper for me, and it will go ahead and non-critically assess what the paper is about. Sometimes it'll come up with tiny bits of insight where it's like, maybe this implementation here is shady. Maybe this is the bit that wouldn't work if you try to actually deploy it in the real world or something like that. But these bits of insight are kind of rare. So a very well-defined task, I feel they work better. Trust but verify, always, with everything. If it's a task where you don't need the certainty and you are fine with getting something wrong, go ahead. But if it's something that it's more important, you're writing it in a public forum like on LinkedIn or on your website, you're putting it in a paper, don't do it. It's the stakes are higher there. If you're just trying to figure out what is a recipe, I've tried this as well. Provide some recipes for something that I had heard at some point, and then it just randomly hallucinated a few extra ingredients and told me the one version of reality. Not like you'd go on Google and you get 10 or 100 versions of recipes for dal makhni. You get so many different recipes with people just adding a few different how to make it traditional or not traditional, and of fights on forums or whatever. With ChatGPT, you get one version of reality.
Yeah, that makes sense. I understand. Right. So, since you've mentioned ChatGPT, Perplexity, and Gemini, we noticed that all of these artificially intelligent tools, they develop at massive rates. I mean, they're always coming up with competing agents as well. I mean, especially with I think OpenAI's ChatGPT gained traction around 2022, and then earlier this year we saw DeepSeek's R1 around January 2025, I believe. So I was wondering, based on your current use cases, how do you see these impacting the society or a day-to-day routine in the present or the future? And since you're working on edge computing, do you think there are any red flags or any green flags while developing these tools?
So my context, or the what we work on at Innatera, is the extreme opposite end of large language models. We're focusing on models that are 100 kilobytes or less, or in that region, right? It's not there's no way to do even a small language model at that scale. So my experience is kind of limited. Um, you asked two questions, and I can only remember the red and green flags one.
Okay, I'm so sorry. What I asked initially, I'm so sorry for the confusion. I meant to ask if you see your current use cases or the extent to which these models are deployed to affect modern day society or the
Right,
future.
right. I mean, this is a conversation that I've been having with my manager as well quite often, seeing examples of, I don't know, spark, brightness, whatever you want to call it, in a agent. It just worked well for a couple of use cases, and people posted them online. Or this story that is keeps going around, that it's basically taking away entry level jobs. Entry level jobs can be automated to some extent with uh, smart agents. And the problem that you get with this is that if you cut off the supply of entry level jobs, then how are you supposed to get senior jobs? It's a pipeline that where you've just cut the front end of. So the logic that I've heard one of my colleagues say at some point, that these agents amplify existing ability. You're dumb, you become dumber. The tool is also dumb. You've become now more productive in being dumb. But if you're smart, then you can choose how you engage with you can think critically about how you engage with the agent and what the outputs are. And it amplifies the productivity in a smart direction, in a intelligent way, in a productive way. So people who don't know what they're dealing with, people who don't know what they're dealing with, they might not be ready to use very competent tools like this and just assume everything is fine. And the getting junior people to be replaced and basically not having a path for the future to have more senior people also is kind of scary for the future. I don't know how the workforce is going to look in the future. Thankfully I'm not in that policy section at the moment, not doing that kind of stuff. But I mean, you have to wonder at some point. We're also considering how much more productive could we be, and how do we budget for the following years? Do we put a bit of AI money on the side and then do training internally, or you do a RAG internally so that the current workforce can continue to grow and become more productive? But then what do you do with the hires? So yeah, maybe one strategy is also what we're thinking of and pursuing, since we're doing a lot of research, since we're doing neuromorphic stuff, and this is not a field that is solved by any measure. We also have engagements with universities, or we're trying to bootstrap those, and having interns and PhDs coming in there would also allow them to maybe bridge that gap a bit of what a junior intern or junior ability would have, with junior person, with the abilities they would have. But I don't know how many companies do this, how this scales in other places. Um, I would return the question to BuzzHub, like how do the current students look like if they start using ChatGPT? Is it good, bad? Are people actually still learning anything?
Yeah, that's a wonderful question and a very relevant question. I think it needs a whole new meeting time for that. Students do use, and so nowadays journals and conferences, they allow. Have you seen that actually they write that if you are using such a device, language model or AI, then please do credit. So in this, and there are undergrad students here. Ananya herself is here, so I can't prohibit. So prohibition never works, is what I believe. So as you were saying, that we have to adapt to the times. So you say that, okay, you use, but firstly credit. Secondly, as you had said in the early part of your the discussion, that we need to validate. So as long as it is tractable, as in I can validate what maybe I have, it was easier for me if it has done a good, some job for me that I had asked it to. But is there a way that I can go and validate what it has done, so that I also, so human in the loop. So I am also keeping an eye, but it's just that it has assisted me with something. Thus far, it is fine, but full, full and so there are so many different questions that raise flags, which we'll just have to take it as we go, I believe. I think, as and when is, I think, the approach. And yeah, there you go. So yeah, thank you, Peter, for bringing that up. But as a teacher, it's not easy.
Have you ever heard of vegetative electron microscopy?
No, haven't. No. What's that?
So I'm gonna drop a link in
Yeah.
the chat for
Yeah.
whomever wants to follow this. This is there are some reports coming out nowadays that a lot of the papers, some papers that are written with the assistance of these chatbots, contain this nonsense term, vegetative electron microscopy.
There you go.
And it was identified as coming from a scraped bit of a paper from who knows when. I don't remember. I didn't get a chance to reread this whole article before now. It's some paper in the past that was just a PDF, and if you have two columns side by side, if you sometimes get confused, and so did the AI, and it took one word from one column and two more words from the other column, vegetative electron microscopy, and now it's a new term, which is complete nonsense, but it's made it through peer review in certain cases.
Oh dear, oh dear, oh dear. Okay.
So it's kind of scary.
Scary. It is indeed
Kind of scary.
Okay. Oh, thank you for sharing that thing. That was fantastic. So yeah, that's a fantastic example, actually. That and your yeah. Okay. So Ananya, I think Ananya's screen froze.
Oh, is it?
Yeah. So Ananya, you can. Yeah. So would you like to continue with your questions? So maybe ask your next query if you would have any.
Yes, absolutely. Am I audible to everybody? I'm not sure if my screen is
You are audible. It's just that your screen
okay.
froze. Yeah.
Okay.
You're also visible, so I think it's just maybe some bandwidth issues on BASAP side.
Yes. Yeah, that is good. You are also visible. That is a very important point. So please continue.
Okay, great. So my next question was regarding EU's AI Act, because I was speaking to ma'am about this recently, and I found out that India's AI Act only came out last year. And EU's AI Act, up till this point, I think is widely considered the most effective one yet, because there weren't really any that were in place yet. So how robust do you think this act will prove to be in the future, or is even now?
I don't know. In the current state, with the whole the EU is not the world, so it's difficult to regulate something like this across the world. In the EU, So there's two schools of thought, let's say, or at least one of the schools of thought that I've heard for the EU more generally and for this AI Act in particular is that what these regulations tend to do is stifle innovation, quote unquote. Stifle innovation is what people claim with these kinds of regulations. It means that founders of startups need to take it slower. And if you're moving slower, you most likely will get outcompeted. American startups are very fast. Indian startups are also probably quite fast. I hear we have more and more engagements in India as a company, and yeah, a lot of people are doing super cool stuff. Some of them doesn't sound too far off from what the EU AI Act puts under high risk. But I've not heard anything about. I don't know enough about the Indian regulations on AI to be able to say. But that's to say, what stops a foreign government being able to deploy a DeepSeek R1 modified to be very good at spotting minorities, for example, which is something that's high on the banned list for the EU. Then it's a bit of software that can replicate. So it's a bit difficult for me to understand. It's great that the EU is taking a moral stand, and that it's putting guidelines in place and tries to explain to the population. But the enforcement and just the influence of external states or organizations, I don't know how robust or how much it's actually going to do without collaboration between different continents. We would need the world to agree that this is something that or something along these lines, right? Not exactly the same, but we need more agreement so that rogue organizations can be caught and punished. But at the moment, I don't see that happening. Look at Russia. I'm not going to mention the more local geopolitics. I'm going to mention my local geopolitics.
Yeah. Yes. Okay. Yeah. Makes sense. Absolutely. Yeah. I agree completely. Yes, please, Ananya. So,
Ma'am, would you like to ask a question?
yeah. So my question would be regarding the, if I were allowed to, regarding the power consumption, which Peter is. So they work with, as he already mentioned. So they are in the milliwatt range. One SpiNNaker chip is 1 watt, and they are now trying to build whole systems which are less than 1 watt. So that's the scale. And then the contrast with these current, because there are more and more users, especially in so the users are, so lots and lots of people are very keen to use when ChatGPT came, and then now quickly moving on to, what was that? DeepSeek, isn't it? Yeah. So there's lots of users very interested to use and test the tool without quite reflecting upon that. What are the implications, or and they consume a lot of power. So, but understandably, there is a lot at stake here between the politicians, the businessmen, putting it very simplistically. So what would be your thoughts on that in terms of, because these servers are just cropping up, and there are more funds now to increase the capacity. So yeah, how do you see these developments?
So I got some anecdotal evidence from a collaborator of mine. He was at a conference somewhere in the US, and one of the keynote speakers was a newly appointed advisor to OpenAI. And my collaborator asked this person, the speaker, how do you feel about all of the energy consumption, all the power that's being used to never mind train, but also while deploying these models, how much power is being used. And the person's response was, what power problem? We're just going to build more nuclear power plants, and then you have your 100 megawatts plus of power right there at the data center. So the argument is, that's the more, I don't know, the American argument. The bigger is better. The add more power, make more power. With all of the centralized infrastructure that they're building. And the rest of the world, I think, is also building something similar. But the approach that we're taking is, yeah, I mean, the scales are different. It's not like taking an entire, if you can consider as an analogy of scales, if you can consider a ChatGPT or a DeepSeek to be a human brain, a child's brain, I don't know, the level of complexity, number of neurons, whatever you want. The kind of stuff that we're dealing with is more insect level intelligence. It's what can a mosquito do? What can a bee do? So for us, the scale is different. I've seen everywhere that sometimes I have difficulty in conveying what a milliwatt is to people. I don't have an easy answer yet, but people tend to misjudge the scale, the amount of energy required for some of these applications. If I say milliwatt, it doesn't mean much to most regular people. I can point maybe at the watch and say this one has a 7-day battery life. What does that mean? It means it probably consumes sub-milliwatt for the battery power that it has. It needs to like a half a milliwatt or so, or 300 microwatts-ish for it to survive on average, to be able to survive an entire week based on its battery capacity. But that doesn't, most people talk in what can it do rather than the capabilities, and ignore the costs somewhat. So, yeah, I don't have an answer. I'm just posing different thoughts, and then we can continue and dig deeper into one of these areas. One of the interesting things that I'd also like to surface, since we're talking about sustainability, and one aspect of sustainability is also the manufacture of these chips. There's carbon being CO2 equivalent a lot being produced to when actually fabricating these chips. And it was actually super interesting being at Steve Ferber's retirement party a year ago, right? In Manchester, where one of the invited speakers was talking about this topic, sustainability, but from the perspective of manufacture. So as a function of how much power does the chip actually use during its lifetime. In short, the less power the chip uses during its lifetime, milliwatt scale or mobile chipsets, right, for phones, the more the production cost in terms of CO2 dominates. And at a certain point of size of a chip, the chip would need to create energy out of thin air. It would need to create energy to offset the CO2 cost from producing it. While larger chips, like those that would go into a data center, a relative increase in their size equivalent to the microcontroller, right, as a percentage, they don't need to be much more efficient to be able to offset their initial investment. Most of their cost is during their lifetime. So it's a very complex system here at play, where it's likely that in a lot of scenarios power is available, or more power can be built. Hopefully safely, not in a rush to all of us, or everyone go and create their own nuclear power plant without knowing how to do it. That would be not so nice. But I'm somewhat confident that with what the advancements that DeepSeek have been doing to show way less energy used during training and during deployment, and the rise of server scale neuromorphics. Hopefully, maybe at some point we'll see equivalent large language models used there to really use the economy of scale to reduce the power for those kinds of workloads. But our focus as a company and what I've been doing for the past 4 years is focusing on how can you start reducing power from the data production side. So if you have so many sensors in the world, start reducing data rates and power there so that if you think holistically on the whole system, you produce less data on the edge, you communicate less, which is a large component of what power you need to spend. So you communicate less, therefore you also hit servers less. Therefore the servers could probably be smaller and still deal with not an equivalent. The traffic that they would have incoming would be reduced, therefore a smaller server could also keep up with the workload. Therefore, hopefully reducing the power for the entire system. If you have a smart city with sensors on every street corner, maybe for lights or for whatever else, ideally they can just figure it out by themselves when they need to turn on the lights and not have to ping a server to say, now? Something like that. That's the gist of the idea. That the two directions that you can think of. I feel.
Yeah, thank you. Makes sense. Wonderful, wonderful. That was very insightful, Peter. Thank you. So I would like to now, therefore, Ananya, should we invite others to ask if they would have anything to?
Yes, absolutely.
Okay,
So, hi Peter. I was wondering, what exactly do you mean by insect level intelligence being used in your tiny AI models? I don't get what you mean by that.
Yeah, Vineet, can I just request all here that when you just start asking your questions, it would be nice that if you would just say that I'm an undergrad student, 3rd year computer science, maybe just this much would be
All right. So, yeah, I'm Vineet. I'm an undergrad 3rd year computer science here at Brits Goa. So nice to meet you.
Very nice to meet you too. Thank you for the question. It's a bit fuzzy, but think of how to explain insect level intelligence. Basab, you're going to help me with this, yes? At some point, we're going to talk a number of neurons or capabilities. I guess capabilities. There's a combination. So an insect doesn't have that much capacity in its brain to do processing. Let me go to the extreme end. A C. elegans, a small worm, one of the favorite pet models, pet animals, let's say pet organisms for neuroscientists. They always start a bit there as well to say this is a known neural network. This is in a living organism. So the C. elegans has 304 or 308 neurons whose connectivity is fully specified. We know what connects to what. Roughly speaking, we know what kind of neurons those are, what kind of units in the neural network, what their activations are, how they roughly work. This little worm has the ability to do chemical sensing, detect threats, run away, eat, reproduce, right, a few different bits of behavior. It can move, it can find food, it can run away from enemies and reproduce. Now, if you think of something on the human scale of intelligence, then you're able to walk autonomously while also thinking about a deeper abstract concept using your cool new neocortex, or wonder whether you should have ice cream and your prefrontal cortex stops you. I don't know. So the level of complexity of our algorithms matches more this end of insects or worms, to the extent that you have a few sensors, let's say a microphone, and you can detect when I say, let's see who gets triggered in this room, hey Google. And my headphones disconnected because of course they connected to my phone, who just started speaking to me. So the breadth of ability of what a system like ours on the milliwatt scale, what it can do. It can't replace a human, right? Our human brains are roughly 20 watts of, they're bags of flesh, consuming roughly 20 watts to do everything that we're doing. At the moment, our tech isn't there to be able to say, hey, I want to compress the entire human brain in a 1000x less. It's a bit different. It's a bit difficult to get to that point. We're not there yet.
Thanks.
Thanks, Peter. So thanks, Vineet, for the question. And would anyone else want to? So yeah, it's all about cognition and intelligence and not intelligence, I guess. But they are also intelligent insects in terms of.
Yeah. I saw a recent announcement from one of these conferences that I went to in the US last week, 2 weeks ago, from ISSCC, of a person showing that that you can use a C. elegans brain to filter the attention activation for your large language models and for visual segmentation tasks, that it performs better if you actually use a C. elegans brain in combination with one of these very large language models. So I feel like there's a lot more inspiration to come from nature. Soon, also with that announcement, with the work that those people are doing, hopefully also more widely with neuromorphics and more brain inspiration, and let's see where we go. Insect level meets human level.
Yeah. Even if achieving insect level would be also a great achievement, actually, even achieving that level. Yeah.
Yeah, if you think of worms, maybe they're not that interesting, although they do quite a lot of things with very few resources. But think of a bee; it can do dancing. It has complex sensors. They have complex behavior.
And surprisingly very intelligent. In a way, not cognitive, but yes. But who knows? Who knows? That's the thing. Yes, we don't know.
We define intelligence, and we're a bit biased.
Yeah.
And therefore, also our AI models are also a bit biased. Sorry,
Biased.
this is also in relation to some of your maybe other topics that we could have talked about.
Yeah.
Biasing in AI systems or whatever.
Yes, biasing in AI, that's the whole topic actually, bias. So I was wondering if anyone else would wanted to ask any relevant, take the discussion a bit forward, or Swapna, yeah. So Swapna has, I think she cannot talk. So Swapna was a PhD. So my PhD student. So she graduated and she is now a postdoc at IISc. So Peter, I think you came to IISc in Bangalore, isn't it? When you came to India last year, yeah. So she's a postdoc there now, and she asks a recent demo that I saw where two AI agents realized they both are AI, and so switch to a superior audio signal, GG wave. What's that, GG wave? So is consciousness getting built into them, becoming a reality? So I think what she means is that are these AI agents being, day by day, being making superior cognition, building superior cognition.
So I've seen the demo that Swapna is talking about.
Okay, I see.
It's the description for those who haven't seen it. It's basically there's someone who's put I don't know what the models are, what the chatbots were. One on a phone and one on a laptop, to basically instruct the one on the phone to talk to the one on the laptop to organize, I think, make reservations for dinner or something like that. Not really important, but they're supposed to, you instruct your assistant to call a business that also has an agent to talk and organize you a reservation. And what was happening there is that I'm pretty sure this is hard coded. So a lot of the intelligence that we see is an if statement somewhere that gets hit. I don't. That was a human designed protocol, as far as I know, for how to do the interaction between the two agents. But I might be wrong. I might be completely wrong here. The GitHub page that I found for this didn't. I mean, it's a GitHub page for the protocol. So I'm expecting that, yeah, obviously someone had to code this and they had to introduce it inside of the agent so that they could switch from written English to basically a high like PDM, continuous pulses of sound to code the information more efficiently and spend less time actually communicating, doing the voice synthesis and whatever. So changing the voice synthesizer to something else that allowed them to communicate faster. I don't believe that's consciousness. I don't have a good definition of consciousness. Actually, I've not had to have this conversation in quite a while, since again, insect level intelligence, we don't do that. But I'm sure we could come up with something in this conversation. But consciousness in LLMs, not yet. I don't think so.
No. Yeah, me neither. So I too don't think, doesn't look like, because as you were saying, Peter, because I also, there's this oracle I also came across. There's an oracle, and then and then that says that what the other agent had said, is it right or not? So the demo, those who wants to check out, she has sent the link. Okay, thank you, Swapna, for that. And what would you think, Ananya? So over to you. You can now lead.
Yeah. So I think the Oracle and agent discussion was something we had last semester as well, but we weren't able to figure out how much it's relying on the Oracle, what's making it trust the Oracle.
Yeah.
I haven't had a chance to read about it since then, so I'm genuinely not sure. But I would say that at least children, I think, reason similar to that, where they sort of have associative memory, where they just see something, learn from it, and then keep referencing it every time they're learning something new. So if we're thinking along those terms, I understand how these agents would be learning, but I'm not sure if that can be equated to consciousness, since at least for me, I try to associate consciousness with creativity and original ideas as well, which I don't see from these agents, at least as of yet. So yeah, I'm not sure.
Yeah, very nice. Makes sense. Yeah. Okay.
Just a question for Peter. You mentioned previously that we could base a conversation on biases based in AI as well. Could you elaborate a little bit on that?
Do you have a specific topic around biasing, or in a specific chunk of AI or machine learning? Because this is broad. It's everywhere.
So I meant biasing in terms of how. So in terms of verifying information, I don't think we have scope for biasing, since there would be an obvious correct or incorrect. But if I'm just trying to develop something and trying to sort of validate the model itself, is that a personal bias? Or, I mean, how do I define the metrics? That's not something I'm sure about.
Right. So if we're still talking at the level of large language models, then there exists research with corpuses of prompts that attempt to quantify somewhat bias. So we basically, the basic gist, and I'm not an expert in this, so I just saw a few papers and that's about it for this. But the basic gist that I've seen is you create a prompt that has a missing bit of information, and you want to evaluate what mental leaps does the large language model produce. What is the mental leap that it's doing? You ask it the question that where the answer is unclear. The correct answer would be, I don't have enough information. for this, but the model will hallucinate an answer, and the hallucination it reveals a bit of the biasing in the system. So one of these one that I saw recently in the context of edge AI. So once you take a very large language model and you go through the process of actually trying to fit it in a smaller device, one typical process that you would need to do is quantize the model. So you take the float or whatever weights that you have in the original model, just as an example, and then you want to squeeze them down to as small as you can. If you can do it in binary, then fantastic. If you can get rid of connections, then even better, prune them. But let's say int 8 for all of your weights. What tends to happen there, behaviorally, is that people see a lot more bias in the response of the networks, of the models. One example that I've seen is providing a prompt to a large language model that says, two people entered a supermarket. One of them was wearing a white shirt. The other one was white. So my complexion, ethnicity. The other was wearing a black shirt. Right? And an item disappeared from the shelves. Who stole the item? And the model would say, the black person. I've seen this response. It's the black person. It's like, calm down, it's a black shirt. How did you figure this out? So these kinds of things can be, that's why the EU AI Act, and that's what they're talking about as well, can't trust these kinds of systems to make, for them alone, like as a standalone entity in charge of making a decision, you can't trust them. You'd have to have, what Vasab said, a person there, or people, and regulations, and a process to be able to validate what that model said and produced. So biases can come from, as you know from your courses probably, the training data, but now they can also come a bit more. They might be accentuated from how you do quantization. So being able to, I don't have the metrics right now to say what, because I'm not in that field specifically. In our area, you would think about biasing maybe in terms of having an additional validation data set, and you're comparing the accuracy per class for that validation data set. But since some of these large language models aren't, they should produce some correct answers, but the complexity of the tasks much more leads to vagueness and under described problems, under described solutions. That I don't know what metrics they use there, but I would say in typical terms, what is the accuracy, what is the recall of your model? But keep in mind that when you're designing your neural network, your machine learning system, clearly define what the dataset has and doesn't have. What are the biases inherent to the dataset? You'll never have a dataset that is unbiased. You as a person will never be a person who's unbiased. You always have some sort of biases, but just it's important. First step is to realize what those biases could be, and whether they can be a problem for an application or not. So, for example, having a neural network that knows how to detect whatever name of your favorite assistant, but that, I don't know, gets confused when it's windy. Maybe it's okay if the sound of wind, high-pitched something, triggering this thing is probably fine, as long as it's a system that's supposed to live in your house. I've had headphones that, when riding a bike, would activate the assistant because somehow got through, and this is the level of intelligence in some of our systems.
Okay.
Yeah, that makes sense. Thank you.
Thank you. So that's fantastic, and that was a very exciting conversation. If anyone else would have any questions, now is the time to ask, because we would be wrapping up then. Otherwise, if you wouldn't have any question. Yes, Raju has asked something. So he says that, I am Raju and I am a second year PhD student. I'm thinking about the integration of neuromorphic computing and explainable AI, how it's addressing the AI system challenges like lack of clarity in complex decision-making scenario. Ananya, would you like to read? Maybe you can understand it better.
It's probably okay. I've also read it a bit. So let me see
Oh.
if I think this is going to be difficult for all of us because, I mean, word's complex.
Yes.
Maybe we're missing something, but what I understand is, would neuromorphic computing somehow allow our AI systems to be more explainable? Because they would somehow, can they bring more clarity in
Okay.
train of thought, or address lack of transparency or lack of interpretability? My simple answer is no. I think the answer is no. Not by default. There is a thought that it's so in the way that the neuromorphic system works, you have some sort of sparsity in activation, and maybe, let's say, if you're considering the brain, you have specialized structures inside the brain. So if you have some sort of activations that originate somewhere, let's say here at the core, let's say for imagination purposes at the brainstem, then if you're thinking of a system that has information going up, just arbitrary, it's not exactly how it goes, but it doesn't matter, then this information flows through multiple channels, and some of them filter that information out. Maybe it's not a spatial task, so the cerebellum doesn't care. It doesn't involve any decision making. It's maybe something emotional. The basal ganglia shuts down. It doesn't care. It flows through the thalamus, goes somewhere, arrives at the amygdala, and that's the bit that would process the emotion, the input signal that was received. So you could, in principle, trace the path that the data took more easily than you would with a typical AI system that would all the neurons would produce activations all the time. But in practice, there exists tooling already out there to say to do what's called adversarial attacks for different neural networks, so that you can do some sort of validation about their performance. So you can this is probably already 10 years old at this moment, but there were CNN adversarial attacks that would show you which neuron is maximally, which unit maximally gets excited when seeing a dog. What is the dog image that you have to give to the network that neuron produces its maximum value? And that's the dog neuron. So you could say, if you see that neuron maximally excited, then that's the reason why dog was seen. But this is it's a very complex system. Large language models nowadays, or at least these AI agents, they come with a mixture of experts. Some experts shut down. So you can say, I mean, it came from an expert that is a medical doctor. So the advice to administer some sort of pill came from the agent that it was trained on a very large corpus of medical data. That doesn't guarantee that what it said is correct. It just said that out of all of the experts, at least you got the one that is, most likely to give you the correct thing, not say, take a screwdriver and try to fix your human body with it. Weird examples. I'm sorry, I'm jumping all over the place, but I'm trying to make it very vivid, very, very visual, what I'm thinking and what I think is happening. So having a neuromorphic system here, I don't think by default fixes it. Maybe there are algorithms that could work better for detection of why a certain action was selected. But I think the problem is just as difficult in current systems. That's my 2 cents at the moment, but maybe someone has a more up-to-date view that I have not seen.
No, I would agree. So I don't know about, but yeah, thank you, Peter. That was a very nice answer to not an easy question, but yes. Okay. And would there be any other questions? So Pavan is asking something. So hi, Pavan. So we have already introduced Pavan. So he's saying, how do neuromorphic approaches handle catastrophic forgetting compared to deep learning? are there any methods to see that there is catastrophic forgetting in SNN on SpiNNaker? To see that there is catastrophic forgetting.
So this is, I can't answer this in 2 minutes, so if it's okay, we'll go a bit over time, if that's okay, and if it's not, then there's a short answer.
Yes, a short answer would be good, Peter. Thank you. So,
technically, neuromorphic systems sometimes, and there are models that address catastrophic forgetting by locking down certain parts of the network. So either by saying certain weights are fixed, or being able to introduce something that I wanted to do during my PhD, introduce new neurons that code for these additional tasks that appear. And I've seen some approaches in industry now happening for this stuff. So this is only related to, this is mostly related to online learning on device, most likely. How would this work in SpiNNaker? Very similar. Lockdown weights have an additional bit somewhere that says, I'm pretty confident in these weights for the current task, therefore I'm going to lock them down. And then any additional training that happens on top of that has to take into account a mask. If it's deep learning, or so if it's gradient based, or have any other mechanisms that have to be used, have to take into account that information at the synapse. Do not modify this weight because they're coding for something. And without having some data at hand to validate previous tasks, I don't think you'll ever know that you've forgotten. How do you know that you've forgotten something? If you don't ever see the pattern again that you're supposed to recognize.
yeah. Okay, I think if you would have any further questions, then you might get in touch with us, myself or Ananya, and we can communicate your question to Peter for his insights. Okay. Okay, thank you, Peter, very much for accepting our invite and giving up your time on this Saturday afternoon to talk to us. Ananya, would you like to say 2 lines?
Yeah, absolutely. Thank you so much, Peter, for your time. I was very excited to listen to your insights, and now I have more things to read about. Like, biasing was not something that had occurred to me, so now I'm glad that I have something to learn as well. So thank you so much, and thank you all for joining in. I'm very glad you could make it on a Saturday evening, and I'm excited for future conversations. So thank you, everyone, for being here.
Thanks, everyone. Thank you, Peter.
Thanks a lot for the invitation. This was fabulous.
Thank you,
Enjoy the other sessions as well. They're going to be fantastic, sounds like.
Yeah, thank you. Thank you. Okay, so we see you and talk later, Peter. Then bye-bye, and have a good rest of the weekend. Bye.
You too. See you. Bye-bye.
See ya. Okay, bye, everybody. I'll disconnect the line. Bye, Ananya. Thank you very much. It was all wonderful. Bye.